Hey guys, in this video we're going to cover 1B.2 and the master learning objective for this video is being able to convert an expression in rational exponent form to radical form by writing the denominator as the root and the numerator as the exponent. So kind of similar to the video that we did before, except for now we're going to have our rational exponents and we want to turn those back into radicals. So don't forget, I'm going to write over here. And yes, you can flip back to your note packet on the other page. Remember that when you have a base, your numerator is going to be your exponent, and that denominator is going to be that root number. So that when you do convert this, again, like I said, that base is going to stay the same. The exponent, that numerator, is our exponent for that base, and our root that comes from the denominator of our exponent is right there inside that little kind of V part of our radical. So let's go ahead and practice that. Looking at the first example number 7. Always nice to just start off with our radical symbol. We see that our base is a 7, so I'm going to go ahead and write that. The next thing is remembering that our exponent, that numerator, is going to be out here as our exponent, and that denominator, which is a 2, is going to be inside here of our radical. Now, thinking about this, since our radical, square root, is the most common radical, do we ever really see this 2 written? Not really. Same thing with this exponent over here as a 1. Do you ever really see anything with that exponent of a 1? Not really. So the answer that you should have is just the square root of 7. Just like that, you don't need that exponent of a 1 or the root of a 2. Next one, looking at example 8. Again, I'm going to start off with my radical symbol. I see that my base is an x. I'm going to take that numerator, which is a 2, and that is going to be my exponent. And then my denominator, which is a 3, becomes our root. That is my answer for number 8. And then I'm going to go ahead and scroll down to number 9. So example 9 and 10 I have here. Number 9, I have two terms, I guess I can say, in the base. So notice when I draw my square root symbol or my radical symbol, I have to keep that base the same. I'm never changing it. So 4a has to stay in parentheses. The rest I can do just like I was doing in the other two examples. So again, that numerator is my exponent, and my denominator is our root number. Once you have everything in its place, you can kind of go ahead and drop the parentheses. So if you also write 4a, make sure that 5 is outside. Do not write it next to the a, because that's going to look like 4a to the 5th, which is not what we want. Go ahead and rewrite our cube root there, and we're good to go. So either one of these answers are acceptable. Sometimes I just kind of like leaving it in parentheses so I know I don't accidentally make the exponent for my a a 5. Example 10, I'm going to draw my radical symbol there. Keep my base together, which is 5x. Take that numerator, which is my exponent, and write my 5 as my exponent. And then my denominator is my root number. So that becomes the 4th root of 5x to the 5th. Again, you can drop the parentheses. Just make sure that you don't write that exponent of a 5 on the x term. You don't want it to accidentally look like its own exponent. I'm going to scroll down here to try to scroll down here, to the last two examples of this video. Now notice that I have 5x to the 1/3 power. 5 has its own exponent, right? It has that invisible 1 there. that you never really write. It's not in parentheses like the previous example, right? We didn't have a parentheses over 5x and the whole thing was being raised there. Everything has its own parentheses. So one thing you need to make sure is that you're only, I'm going to go ahead and put a little asterisk here, is only put fractional, so something that has a fraction, so only put fractional exponents inside the radical symbol. So remember, that's kind of like that square root sign. Alright, so if you look at 5 to the first power, is that exponent a fraction? No, it's not. So that 5 is going to stay outside of our radical symbol. The rest, however, when I'm rewriting x to the 1/3 power, that 1/3 is a fraction. So that's how I know my x is going to be inside that radical. The rest kind of stays the same. I take the numerator of a 1, that's my exponent on my x. I take the denominator of a 3, that's my root number. And I can rewrite this to have a final answer of 5 times the cube root of x, because I don't really need that exponent of a 1. I never really see it. Likewise here, for example number 4, you still need to keep that in mind of only rewriting the terms that have a fractional exponent. So in example number 12, we noticed the same thing as the previous example, that 6 has a power of 1. That 1 is not a fraction. So when I have my radical symbol, I need to make sure that that 6 is its own whole number in front of the radical sign, right? They're still going to be multiplied later on. My base, however, x raised to the 7/4, that base has a fractional exponent. So x needs to be inside. That numerator of a 7 is on my exponent, and my denominator of that 4 becomes my root number. So I'm going to have a final answer of 6 times the 4th root of x to the 7th power. And that does bring me to the end of this video, so you can go ahead and find activity 1B.2 in your activity packet.